Good afternoon, everyone. I just welcome all the first sem generic students to Physics Department Equity College, and this is my second lecture on differential equation of the first order and first degree. So let's begin. So we were studying about methods for solving the differential equation of the first order and first degree. So in the last class or in the previous lecture, we have discussed about equations solvable by separation of the variables. And I hope that you were able to solve the questions that I gave you in the assignment related to this method. Today we will see these homogeneous equations. So let us proceed. A differential equation of the form dy by dx is equals to f of x comma y divided by phi x comma y is called a homogeneous equation if each of f of xy and phi of xy is of same degree. So this is the simple definition of a homogeneous equation, or you can understand what is the format of a homogeneous equation. This is the format of a homogeneous equation. So let us try to understand this homogeneous equation with the help of an example. Suppose I have written here, that is dy by dx is equals to 3xy plus y square divided by 3x square plus xy. So in this case, if you see, what is the degree of this function, that is f of xy? You just consider this is the function f of xy. So what is the degree here? If you see, here the degree is 2, 1, 1. So 1 plus 1, 2. Here the degree is 2. Here the degree is 2. Here the degree is 2. That is 1, 1, 1 plus 1, 2. So we see that the degree of the upper function and the degree of the lower function is same. If it has been so, suppose if there was no y, just omit y here. Suppose I have just omitted this y here. Now if you check the degree of this part and this part, is it same? Here the degree of this variable is 1. Here the degree of this variable is 2. Here the degree is 2. Here the degree is 1 plus 1, that is 2. So we see that the upper function and the lower function are not having same degree. So this is not an homogeneous equation. So that is what I mean to say by same degree of the function f of xy and function phi of xy. I hope this must be clear to you. So let me again make this a homogeneous equation by writing here simply what? Y. So this is now a homogeneous equation. Now what is the procedure to solve this type of equation? I will take the same example only, okay? And I will move to the next page. So to solve such equations, we have to consider, that is, let y is equals to, y equals to v of x, or you can simply write putting y is equals to v of vx. Now if you differentiate this, what we are going to get with respect to x, you just differentiate it, that is dy by dx. So certainly we will be getting this, that is v dx by dx plus x dv by dx. So that is v plus x dv by dx. So this is what we are getting, and this is the way to solve a homogeneous equation. So after getting this, we can reduce this further. Okay. Now what we can do? We can simply write, that is v plus x dv by dx. This will be equals to what? What was our equation? 3 of xy, right, plus y square, then 3x square plus xy. So in place of y I am going to write what? Vx. So let me write in place of y Vx. I'm just removing this y here, and instead of y I will be writing what? Vx. So let me write here. So let me write here Vx. Here it will be Vx whole thing square, and here it will be Vx, right? So this can be further written as, so if you see, I have what? 3x square v plus v square x square, 3x square plus x square v. So I can take x square common in the numerator part as well as in the denominator part, and I can cancel it. Then I will be left with 3v plus v square by 3 plus v. So this is what I am left with. So finally I can write what? That is v plus x dv by dx is equals to 3v square, sorry, it's not v, 3v plus v square divided by 3 plus v. So now what we can do here, we have only two variables, that is v and x. So we can proceed further by the method of separation of the variables. So if we proceed for the separation of the variables, what we have to do? We have to bring v one side and x on the other side. So let me take v one side, say this v will go that side, that is I can write x dv by dx is equals to 3v plus v square by 3 plus v minus v. So this will be what? 3v plus v square minus 3v minus v square divided by 3 plus v. So this can be further written as, so v square cancels out, and 3v cancels out, so it becomes 0. Okay, so x dv by dx is equals to 0. It means what? V is some constant that is equals to, say, c, where c is some constant. Okay, so v, in place of v I can write what? Y by x is equals to c. So this is the solution of this differential equation. So this is my answer here. Okay, let us try to understand this with the help of another example. Suppose we have another question, that is solve 2xy plus x square y dash I think you know, it is dy by dx. This equals to 3y square plus 2xy. So this is the question. Now what will be the solution for this? So at first we have to check whether the degree of this function and this function is same or not, because we can see we have two functions here. Okay, this function and this function. So let us rearrange this. That is, we can write y dash. Okay, let me at first write the question, that is 2xy plus x square, 3y square plus 2xy. So this can be further written as 3y square plus 2xy divided by 2xy plus x square. Now if you check the degree here the degree is 2, here the degree is 2, here the degree is 2, here the degree is 2. So it is a homogeneous equation. So this can be further written as what? Dy by dx is equals to 3y square plus 2xy divided by 2xy plus x square. Now let us putting what? Y is equals to Vx. We get ddx of Vx is equals to 3Vx square plus 2xVx divided by 2xVx plus x square. So if you see this part, this can be written as V plus x dv by dx, which is equals to 3v square x square plus 2x square v divided by 2x square v plus x square. So if you take common x square, we will be getting what? 3v square plus 2v divided by 2v plus 1. Okay, so this is what we have got. Now we can write dv by dx is equals to 3v square plus 2v divided by 2v plus 1 minus v. So if you simplify it, you will be getting v square plus 2v minus 2v square minus v divided by 2v plus 1. So if you simplify it further, you will be getting v square plus v divided by 2v plus 1. So this is what we have got, that is x dv by dx is equals to this. Now let us take x on one side and v on the other side. So we can write that as 2v plus 1 divided by v square plus v dv is equals to 1 by x dx. Okay. After that, we can integrate. Okay. So we can write integrating both sides, we get, so integration. So here we had what? 2v plus 1 divided by v square plus v dv is equals to integration dx by x. So this is what we have. Then we can write what? If you can remember, the formula for this can be achieved by just differentiate the lower part here. The differentiation of the lower part will be equal to the upper part, that is the numerator part. Okay, so if you get this condition that differentiating the denominator part you get the numerator part, then we can write what here? Log or ln. Okay, so you simply write log v square. We have to write that denominator part because differentiating the denominator part we get the numerator part. So we can write in this way, that is log v square plus v is equals to log x plus some constant, say log c. So this is equals to what? Log v square plus v is equals to log xc. Why? Because this is the formula, na? Log a plus log b is equals to log ap. So this is the formula, and based on that formula we have written this. Now we can take out the log from both the sides and we will be left with v square plus v is equals to xc. Now you put the value of v. We have already taken what? V is equals to, sorry, y is equals to, since y is equals to what? V of x. Therefore v will be what? Y by x. So y square by x square plus y by x is equals to xc. So this is the solution of this differential equation. You can stop here or you can do the further calculation also if you wish. So you must get this as your final answer, that is y square plus xy is equals to cx3. By doing the LCM, I am getting this format of the final answer. So this is your final answer of this question. Let us see one more problem. Say we have the question that solve dy by dx is equals to y by x plus x sine y by x. So in this question you can see that the degree of this function, okay, let me consider this as a whole function. Here the degree and here the degree is same. Here the degree is 1, here also the degree is 1. So we can write that solution dy by dx is equals to y by x plus x sine y by x. So this is a homogeneous equation. Now let us putting y is equals to v of x. So therefore ddx vx is equals to, sorry, vx by x plus x sine vx by x. So if you just do further simplification, you will be getting what? V plus x dv by dx is equals to v plus x sine v. Now you can do the separation of the variables. So certainly v and v will cancel out and you will be left with what? X dv by dx is equals to x sine v. So if you see here, we will be left finally with what? 1 by sine v dv is equals to, here x and x will cancel out and we'll be left with only dx. So integrating both sides, we get, so if you integrate, it is 1 by sine v dv is equals to integration of dx. So integration of 1 by sine v dv will be equals to what? We can write. So further we can write what? In place of sine x we can write cosec v dv is equals to integration of dx. So we know that integration of cosec v will be what? It will be log 10 v by 2. So this is the formula which will be equals to x plus c. So if you simply put the value of v, you will get your answer, that is 10 y by x divided by 2 is equals to x plus c. Or finally we can write what? Log tan y 2x is equals to x plus c. So this is your final answer. So let me stop here only for this homogeneous equation. Okay, please try to do some problems from some given reference books. Okay, and if you have any doubt, please ask me in comment section, or you can give me messages in the Google Classroom. Now the next topic that we have to discuss is what? Linear differential equation. So we have discussed what? Homogeneous equations. Now we have to discuss this linear equations of first order or linear differential equation. So let us see what is this linear equation of the first order. So a differential equation of this form, that is dy by dx plus p some function of x into y is equals to q some function of x. So this form is said to be what? Linear differential equation. So let us see, if we get a linear differential equation, then what are the steps to get the solution of such linear differential equation of first order and first degree? So here at first we have to find the integrating factor. So at first in the solution part you will be finding first what? Integrating factor. So what is the integrating factor? Integrating factor is equals to e to the power integration p, which is a function of x into dx. So this is our integrating factor. So at first we have to find this. In short we write what? if. Okay, in short we write what? Integrating factor, that is I dot f is equals to this. And then the solution of the linear differential equation can be written in this format, that is y into integrating factor is equals to integration q, which is a function of x, into integrating factor dx plus c. So this is the format of the solution. Remember, this is the format of the solution of a linear differential equation. So I hope this is clear to you. So let us try to solve a problem and try to understand this in more details. Suppose we have a question that solve x plus 1 dy by dx minus y equals to e to the power x plus 1 whole thing square. So this is the question. So to get the solution of this, at first we have to check whether this is a linear differential equation or not. So let us at first check this. So we'll write the question again. So this was our question, right? Now if you check that there is dy by dx, along with that some function of x is there, and here there is nothing, means there is no p, or you can say there is no function of x. Simply you divide both sides by x plus 1, then we will get the format of linear differential equation. So let me divide. So if I divide with x plus 1 on both sides, what I am going to get? I will be getting what? Dy by dx minus 1 by 1 plus x plus 1 into y is equals to e to the power x plus 1. This I will be getting. So this is the form of the linear differential equation. So what is the next step that we have to do? We have to find the integrating factor. For that, so at first we will be writing what here? P is equals to what? Negative of 1 by x plus 1. Remember, you have to take the sign also, that is negative here. And Q is what here? E to the power x plus 1. Okay, So this is our P and Q. Therefore, integrating factor IF is equals to e to the power integration of negative of this function, that is P, into dx. So it will be what? E to the power minus integration 1 by x plus 1 dx. Now we know that if we differentiate the denominator, we are getting the numerator here. So it comes into the formula of log. So minus, we can write here what? Log x plus 1. Okay. Now if you take the negative sign there, means I'm just applying the concept of log here. So we can write this as log x plus 1 to the power minus 1. Now we know that exponential of log of something is what? That something. So that something is this. So I will be writing this, which can be further written as 1 by x plus 1. So this is our integrating factor. Therefore, our solution will be solution is y into integrating factor is equals to integration q of the integrating factor, q into integrating factor dx plus c. So you just put the integrating factor here. The integrating factor is x plus 1. This is equals to integration, what was q? E to the power x, x plus 1, 1 by x plus 1 dx plus c. So here if you see, this and this will cancel out and we will be left with what? Integration of the e to the power x dx plus c. Integration of e to the power x is what? E to the power x only. Okay, so this is our solution. So our final solution will be y by x plus 1 is equals to e to the power x plus c. So this is the solution of this linear differential equation. Let us see another problem. Say we have the question that solve x into x minus 1 dy by dx minus x minus 2 y is equals to x square 2x minus 1. So this is the question we have. Let us see the solution part of this. So here p is what? Sorry, we have to rearrange this, right? So we'll be at first rearranging this. So dy by dx, and here it is x into x minus 1 minus x minus 2 y is equals to x square 2x minus 1. So here we will be dividing both sides by this x into x minus 1. So x into x minus 1 dy by dx minus x minus 2 y divided by x into x minus 1 is equals to x square 2x minus 1 by x into x minus 1. So after dividing this, we are going to get what? Dy by dx minus x minus 2 divided by x into x minus 1 y is equals to x square 2x minus 1 x into x minus 1. So here, so this is the form of the linear differential equation. Here p is equals to minus x minus 2 by x into x minus 1 and q is equals to, if you further simplify this, you will be getting what? X into 2x minus 1 by x minus 1. So here q will be what? X 2x minus 1 by x minus 1. So this is our q and this is our p. Now we have to find the integrating factor. So integrating factor if is equals to e to the power integration of p dx. So which can be written as exponential or e to the power integration of minus x minus 2 divided by x into x minus 1 dx, which is again equals to, so see this part we can simplify, so that we can get a proper answer. So we will be simplifying this. I think you have learned this technique in your junior classes, so I'm not going to discuss this how I have just simplified this to this. Okay, so let me give this bracket into dx. Then we'll be getting what? This will be equals to e to the power, so after integration you will be getting log e to the power log x minus 1 minus 2 log x. So this can be written as e to the power log x minus 1 by x square. See, this can be further written as log x minus 1 minus log x square. So what the formulas are, I am just using the formula of log, okay, that is log a minus b is equals to log a by b. Anything to log a is equals to log a to the power that something that is n. So these are the formulas which I have used here, okay. So after getting this, we know that exponential of log of something is that something only x minus 1, that is x square. So this is what our integrating factor. Now solution is y into the integrating factor, that is x minus 1 by x square, is equals to integration q. What is q here? That is x 2x minus 1 by x minus 1 into x minus 1 by x square into dx plus c. So this can be further written as y into x minus 1 by x square is equals to integration of x, that is 2x minus 1 by x. Here it will be dx plus c. So if you integrate this, we can simply do what? 2 minus 1 by x I can write. So this will be what? 2x minus log x plus c. So this is what we are getting. Okay. So this is our solution. So in this way we can solve linear differential equations. So for today only this much, and with this I am just ending my lecture. Thank you.